Okay, so this is problem 37 from chapter 6 of Giancoli 6th edition. This is not a difficult problem, but sometimes students forget little details about it. So let's solve it together. So what we have is a trampoline artist of a certain mass that is given to us, and she jumps vertically upward from the top of a platform. So let's make the platform here, and here we have our artist that is jumping up with a certain initial speed v1, which is given to us. Okay, and the height of this trampoline is also given to us is 3 meters. Okay, and then comes a sequence of questions. So the first one is, how fast is the artist going as he lands on the trampoline 3 meters below? Okay, so we want to know the speed v2, the speed that this person has when he just reaches the trampoline. Okay, we are going to use conservation of energy to solve this problem. Remember that to write the gravitational potential energy, I have to choose one point as my reference and to call it 0. And in this problem here, I'm going to call this point here, which will be the position y2. I will call this point 0. So y2 is 0. Okay? All right, so let's solve this problem. What we have is conservation of mechanical energy. So the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy plus the final potential energy, gravitational potential energy. So initially we'll have kinetic energy. So we have 1/2 of mv1 squared. So everything here we know, everything is given. We also have mg y1, and y1 we know, according to our choice, is 3. And then at position 2, we'll have 1/2 of mv2 squared. v2 is our unknown, and the gravitational potential energy, but since I chose this position here to be 0, I will just have 0. So from this equation, we'll find v2. Not bad. Simple problem. Let's move on to problem B. And what do we have in problem B? They say that the trampoline behaves like a spring, and they give us the spring constant. Okay, and they want to know how far does the artist will depress this trampoline. So the idea is, once the artist falls on the trampoline gets, let's make this drawing here, gets deformed, gets depressed, and here's the artist. So we want to know by how far it will be depressed. So I'm going to call this amount y. Okay, all right, so to compute this y, I'm going to use conservation of mechanical energy, the initial sum being equal to the final. Now, what I'm going to choose as initial is up to us. I can choose the point 1 as my initial, or I can choose the point 2 as my initial. Okay, so what I'm saying is I can choose K1 plus P1 as my initial, or so either I choose K1 plus P2 or K2 plus P2, because we just found above here that they are the same. Okay, okay, and this will be equal to this 3, this scenario 3. And what do we have in this scenario 3? Okay, I'm going to write everything: kinetic energy plus gravitational potential energy plus elastic potential energy, and let's see what we'll keep from that. The final kinetic energy is 0, because we will depress the trampoline until we stop. Now, this is the important step that sometimes the students forget, that we also have gravitational potential energy. And so my choice here was 0 at this point. Now I'm below that point. So I have negative, So let's remember to put this minus sign here. Negative minus mgy. This is the amount that gets deformed that I do not know and I'm trying to find. And I also have elastic energy, potential energy given by 1/2 of k y squared. The y is what we are trying to find. Okay, so on the left side here we have just a number, and on the right side we have two terms involving the y, the unknown, the variable. You see that this is a quadratic equation, so you have to solve a quadratic equation, and you will see that two answers will come out. One is positive and the other one is negative. We are going to keep this one, the positive direction, the positive solution is what we are interested in because I already took into account the sign here. The negative solution is wrong. So that's what the students need to pay attention. So two important details here. Let's repeat it. We do have gravitational potential energy being negative because it's below the point that we called 0. And once selecting the solutions, I'm going to select the positive one if I already took into account the negative sign in the equation.